so chapter 5, chapter P, section 5A, okay, because we're going to divide 5 and I think it's 3 parts, is called rational expressions. So we're basically taking something that is a fraction that is made up of an expression. We're going to see if we can simplify it by factoring and canceling out like terms. So before we get into that, we want to review what's called domain. Domain on a function or an expression is the values in which you can plug in for x. The overall answer for domain would be all real numbers, except when there are 3 cases. The first is if there's a variable in the denominator. So if there's a variable in the denominator and we want to figure out what x can't be, we take the denominator and we set it not equal to 0. Because what happens if the denominator is 0? What happens to my whole fraction when you divide by 0? It's undefined, okay? When you divide by 0, it's undefined, which is why you can't have something that would make your denominator 0. So if there's a variable in the denominator, we set it not equal to 0, and we would then find out what x cannot be, okay? If there's a variable under square root, whatever's underneath the root has to be greater than or equal to 0 because we can't square root a negative number. And then the last one is a combination of the two. There's a variable under the square root in the denominator. So let's say it's 1 over something with a square root. Now what's in the bottom has to be greater than 0 because it can no longer equal 0. It's the overlap of those two. We will come back to domain later in the year. The most important part is this top one for now, because we are going to get expressions that have a variable in the bottom, and we have to find out what would make that 0, and then we have to make sure that we don't include that answer in any of our solutions. So like it'll say something about an extraneous root, or it will say check your denominator for restrictions, and that's what it means. It means what would cause the denominator to be 0, which would lead to the whole thing being undefined. All right. We start with simplifying fractions, okay? So on the left side are all examples of things that can be simplified. On the right, things that cannot. If you look at the left side, and we'll start with your basic just numbered fractions. If I have 6 over 30, what does that become? 1 over 5, okay? Because 6 goes into both the numerator and the denominator. If I have 3x over xy, how does that simplify? Is there something in both the top and the bottom I can cancel out? The x, good. So the x's would cancel and I'd get 3 over y. And I can only do that because that was multiplication. In the next one, I have 2 times x plus y over 5 times x plus y. The 2 and the 5 do not simplify, but this exact same expression is in the numerator and the denominator, so I can cancel it out. I cannot cancel part, like I can't cancel x and y, but because this is the same exact sum or difference, I can cancel that whole thing out, and I just get 2/5. Now the next one is x plus y, the same thing as y plus x. Does order matter if it's addition? It does not matter. So these are the same. I can do the same thing here. I can actually cancel these, and I'd get 2 over 5. If you look next to it, here's an example of something that could not be done that way. Plus and minus are 2 different things. So on the right-hand side, that 2 times x minus 5 over 5 times x plus 5 would actually stay exactly that way. You cannot cancel out a sum and a difference. They're different. I'll come back to that last one, but if you look over here as well, on the right-hand side, there's a sum in the top and a product in the bottom. I cannot do that. You cannot cancel the x unless it was on both terms. So if it was 3x plus x over x, now you can cancel out the x, but it has to be on every single term. All right, and then the last one on the left, on the bottom, These are not exactly the same, okay? These have the opposite signs. So the x in the top is positive, in the bottom it's negative. The y in the top is negative, in the bottom it's positive. So you can, and I'm going to show you the long way around it, but then I'm going to show you a shortcut. You can actually take out a negative 1 on the bottom. So I'm going to rewrite the top. Take out a negative 1. So if I divide by negative 1 and negative 1, I end up with negative y plus x. And although the order is different in the top and the bottom, the signs are now the same. These two could be canceled out. I'd end up with 1 over negative 1, which is just negative 1. I could have done the same thing by taking out a negative 1 in the top and then canceling them. It wouldn't have mattered. So that's the long way to do it. The shortcut is when you see two expressions that have the same variables or same terms, but they are opposite signs, you can cancel them out, and you have to leave a negative 1 in one of the spots. It doesn't matter which one, but you have to leave it in one. So if I had x minus y over y minus x, I could literally cancel these out and make it negative 1. I could have put the negative 1 in the top or in the bottom. Either way, this is going to end up with a negative 1. All right, so we're back to just simplifying. All right, so look at these. How can I simplify number 1? What goes into both 4 and 20? 4. This would be 1 over 5. Go to 2. How can I simplify this? Cross out the y's. It's multiplication, so I could literally just cross them out. I'd get x over w. Go to 3. How can I simplify this? Good, trick question. You can't. Okay? This cannot be reduced. The x's cannot be canceled out because it's a sum. It's part of a sum or difference. How about 4? Now I can cancel out the x's, and I get just x plus 1. All right. Now we're going to do 5 is pretty similar. 5 and 7 are pretty similar, but when we get into 6, we're going to pause for a second. Go to 5. What can I do here? Good. The 3 becomes 1. The 6 becomes 2. And then x cancels out, and there would be 2 x's in the bottom, right? You could go through the process of subtracting your exponent. Or if there's 1 in the top, 2 in the bottom, we're going to cancel 1 out. And I'm just going to be left with 1 over 2x. We're going to save 7 to start tomorrow. Well, after the quiz. So now go to 6. If you look at 6 and 8, now we have expressions in the top and the bottom. So the first thing we're going to do is check to see if we can factor in both spots. So if I look at the top here, can I factor x squared plus 4x minus 12? How do I factor if there's 3 terms? The first and the last are not perfect squares, but there's only a 1 at the front. What's the method? Good. Are there factors of negative 12 that sum to positive 4? Positive 6, negative 2. So then I'd replace, or I do x plus 6 and x minus 2. Now that goes over. Can I factor from 3x minus 6? How do I do that? Take out a 3, and I'd get x minus 2. Can I cancel something out? Good. The x minus 2, again, it's a sum or difference, so the whole thing has to match. And now I just get x plus 6 over 3. go to 8. Look at the numerator. Can I factor that out? Are there factors of negative 20 that sum to positive 8? It would be a negative 1 and 20, a negative 2 and 10, and that's the one that gives me 8. So my numerator is x minus 2 and x plus 10. And then I repeat that for the bottom. So the factors of 10 that sum to 11 would be 1 and 10, x plus 1, and x plus 10. Is there something there that can be canceled out? Good. And I'm left with x minus 2 over x plus 1. All right, what can you do to factor the top of 9? Good. So I get 4 and then x plus 3. And what are the factors of negative 18 that sum to negative 3? Positive 3, negative 6. So now the x plus 3's cancel, and I'm left with 4 over x minus 6. You cannot simplify that 4 into the 6. Don't do it, okay? You can't simplify part of a sum or difference. Okay, when we look at 10, so the numerator, the order of the values are opposite what we're used to. You can, of course, switch them around, okay? Or you can just work backwards. So I could look for the factors of positive 12. That would sum to the positive 1 with these x's being a positive and a negative. So you can do this. I can make the factors of that x squared a positive x and a negative x. And then fill in, by using trial and error, the factors of 12 that would make the outer and the inner add up to positive x. Okay? Or you can switch around your order. You can take out a negative 1, making that first term positive, and then you'd be looking for the factors of negative 12 that sum to negative 1. At the end, you will always get the same thing. God bless you. So if I do this, this has to be a positive 4 and a negative 3. This would be a negative 4x. This would be a positive 3. So my value is right, but my signs are wrong, which means I'm just going to switch these. This would become positive, and this would be negative. And now I'd get the positive 4x and the negative 3x, which is that positive x. Then in my denominator, I have a value at the front this time, so you can either do trial and error or you can do first times last. So 2 times 4 would give you 8. Factors of 8 that sum to negative 9 would be negative 1 and negative 8. Replace that middle term with them. And factor by grouping. And then what's inside the parentheses matches, and what's grouped together, or what's left gets grouped together. So I get 2x minus 1 and x minus 4. Now, there are no two parentheses exactly the same, but there are a pair of opposites. So we said if you have opposites, you can cross them out as long as you make one a positive 1 and one a negative 1. So I can put the negative 1 here. I can put the negative 1 at the bottom. It doesn't matter where that goes. And your answer can be written as negative 3 plus x over 2x minus 1. Or you could distribute that the negative in. And either of these would be kept as an answer. Yep.
I'm a bit confused on the canceling out part because I got x plus 4 at the top and x plus 4.
So how did you factor at the top? Do you have x plus 4 and 3 plus x?
Yes.
That doesn't work, so let's figure that out. So which way did you do it? How did you factor 12 plus x minus x squared? How do you factor it? Did you do first and last? Did you rearrange it? What'd you do?
I rearranged it.
Okay, so negative x squared plus x plus 12. And then did you leave the first one negative?
Yeah.
Okay, so then you're looking for the factors of negative x, which would be x and negative x. And then the factors of positive 12. So you can do positive 4 and positive 3, but then you have to test it. 3x minus 4x, that gives you a negative in the middle, which means you have to switch the signs. Or actually, you have to switch the spots because the signs are on the x. And then you check it from there. Negative 3x, positive 4x, that gives you the positive x. That's the middle term. So that would be your numerator, x plus 3, and negative x plus 4, over your denominator, 2x minus 1, and x minus 4. So these, again, are opposites. I can cancel them out, but I have to put a negative 1 somewhere.
Wait, what do you mean, like, where's taking a negative from?
If you cancel out opposites, you could factor out. The long process is factor out a negative 1, then they become the same, then cancel them out. The shortcut is when you see opposites, so same terms, one's got a positive, one's got a negative, and where those signs are switched. So in the top, I have a negative x and a positive 4. In the bottom, I have a positive x and a negative 4. Those are opposites. So you can cancel them out, but you have to put a negative 1 in the space of one of them. It doesn't matter which one.
In the space of one of
The ones you canceled out. So we canceled out 2 things. This one and this one. One of them you can cancel and put a 1, but the other one has to get a negative 1. It's going to happen again for 12.
Can you zoom out so I can see?
Yeah. You're welcome. What can I do in the numerator of 12? Take out a 4. So 4 comes to the outside, and this is 3 minus x. In the denominator, x minus 3. So they are not the same, but they are opposites. I cancel them out. One gets a 1, one gets a negative 1, which means this is just negative 4. All right, so for the first one, what kind of factoring is it in the numerator? Different to 2 squares. So this becomes x plus 5 and x minus 5. And then my denominator is 5 minus x, and that can't be factored. But there are opposites there, right? Nothing exactly the same, but there are opposites. So I can literally cancel through them. One gets a 1 and one gets a negative 1. Because there'd be no denominator here, I would probably put the negative 1 in the top. Otherwise, you have to simplify it again, but it doesn't matter. As long as your signs at the end, you could either have negative x plus 5, you could have negative x minus 5, you could have negative 5 minus x. Doesn't matter. Any of those answers are fine, okay? You don't want to leave it as something over a negative 1, though. That can be simplified. So again, if it's the only thing in the denominator, I tend to put the negative in the top, but it doesn't matter. As long as at the end you simplify it, you don't leave it over negative 1. Sophia, you had a question?
No.
Okay. All right, 14. What can I do in the numerator? 4x. Greatest common factor would be 4x. And I'd get 1 minus 2x. Denominator, greatest common factor is 5. And I get 2x minus 1. So again, not the same, but opposites. One gets a 1 and one gets a negative 1. This time, you're either going to have a negative in the top with the 4x or in the bottom with the 5, and it doesn't matter. So if I put the negative 1 in the top, you get negative 4x over 5. If you put it in the bottom, it'd be 4x over negative 5. If you put it out front, that's also okay. It could be negative 4x over 5. Okay, it just can't go in both places. So any one of the 3 of these would be fine. Questions on that one? All right, 15. How many of you rearrange your numerator? Okay, so if I rearrange it, I'm going to make it negative x squared plus 3x plus 4. Did you then take out a negative 1? Yeah, okay. Negative 1, x squared minus 3x minus 4. And then factor that. Factors of negative 4, that sum to negative 3 would be negative 4 and positive 1. So that's my numerator. Denominator, you can either do trial and error or you can do first and last. First and last would be 2 times negative 4, which is negative 8. factors of -8 that sum to -7, -8, +1. Replace your middle term with those. And then factor by grouping. So from the first one, I could take out a 2x. I get x minus 4. The second one is already x minus 4, so I group those together. And what's left over goes in the second set of parentheses. So x minus 4 and 2x plus 1. This time, the x minus 4's cancel. And I end up with, and again, the negative p on the front, negative x plus 1 over 2x plus 2. Or you could distribute that, negative x minus 1 over 2x plus 2. Those would both work as answers. Yeah.
Where's the negative one?
If in this one, we took the when we rearranged the numerator, we took the -1 out just so that that leading coefficient was positive.
Oh,
So either of those works. Okay, and then last one. This time, what's in the top? Difference of two squares, so that's x plus 1 and x minus 1. And in the bottom, we're going to factor by grouping. I'm going to put the parentheses around these. From the first set of parentheses, I can take out an x squared, and I get x plus 1. Second set of parentheses, I can take out a 9, x plus 1. And I get x plus 1 and x squared plus 9. Can you factor x squared plus 9 any further? No, why not? It's a plus. There's no such thing as the sum of two squares, right? There's a difference, but not a sum. So then from here, the x plus 1s would cancel, and I get x minus 1 over x squared plus 9. Questions? Okay, so your homework is on WebAssign. I think it's already on there. I made it due Wednesday so that if you want to focus on your quiz again for this evening, you can. If you want to start this homework because it's good practice because there's factoring in it, okay, and then have a little bit of a lighter load tomorrow, you can. But either way, this assignment will be due Wednesday morning.